Planck's quantum theory or particle nature of electromagnetic radiations. Electromagnetic radiations have dual character, that is wave nature and particle nature. We already discussed wave nature of electromagnetic radiation. With that could only explain the two properties of electromagnetic radiations like diffraction and interference. But it could not explain the following observations like first one, black body radiation. Black body radiation means emission of radiation by hot bodies. Okay. And the second one is photoelectric effect. Photoelectric effect means ejection of electrons from the metal surface on the absorption of radiations, or the radiations fall on it. Okay. Third one is variation of heat capacity of solids. Heat capacity of solids as a function of temperature. Okay. And fourth one, atomic spectra of hydrogen. All these properties could not be explained by the wave nature of electromagnetic radiations. Okay. So, a new theory was put forward by Planck, Max Planck. Max Planck in the year 1900. And this theory is called as the Planck's quantum theory. And the main postulates of this theory are, first postulate, that is atoms and molecules absorbed or emitted radiant energy discontinuously in the form of small packets of energy called quanta. Okay, atoms and molecules absorbed or emitted radiant energy. Okay, radiant energy discontinuously. Important, discontinuously. That is, they emit radiation in the form of discontinuously in the form of small packets of energy called as quanta. Packets of energy called as quanta. Quanta is the plural form. So each quantum of radiation is associated with a definite amount of energy. Radiation is associated with a definite amount of energy. This is the first postulate. Okay. So this is the first postulate. Now second postulate is amount of energy associated with a quantum of radiation is proportional to the frequency of the radiation. The amount of radiation or amount of energy, the amount of energy associated with a quantum of radiation. Okay, with a quantum of radiation is proportional to its frequency. Is proportional to the frequency of the radiation. Okay, to the frequency of the radiation. Or we can write E is the energy, okay, which is proportional to nu. E is the energy of that radiation and nu is the frequency, or E is equal to h nu, where h is called as the Planck's constant. Planck's constant. Okay, and h is equal to 6.626 into 10 raised to minus 34 joule second. Okay. Now, this is the second postulate. Now, the third postulate, a body can absorb or emit energy only in terms of whole numbers, whole number multiples of quantum. Okay. Third one, a body can absorb or emit energy only in terms of some whole number multiples of quantum. Okay, whole number multiples of quantum. Whole number multiples of quantum. Okay, so we can say E is the energy is equal to NH nu. Okay, N represents the whole numbers ranging from 1, 2, 3, etc. Okay, this N never become a fractional value. Okay, also this means that energy is equal to h nu. Then if N is equal to 2, 2h nu. Okay, 3h nu. These are the different packets of energy emitted or resolved by any radiation, by any body. If a body can emit or absorb energy which will be equal to h nu, 2h nu, 3h nu, etc. This N will never become a fractional value. That is, fractional value emission or absorption by a body will not takes place. Okay, so N will always be a whole numbers. Okay, now let us do one problem based on this. Okay, calculate the energy of a radiation having wavelength lambda equal 4000 angstrom. So given lambda equal 4000 angstrom. We know the equation is equal to h nu. Okay, so lambda is given, so E is equal to hc by lambda. We know h is equal to 6.626 into 10 raised to minus 34 joule second. Okay, joule second. And C is given, C we know 3 into 10 raised to 8 meter second inverse. Now lambda is given, lambda equal 4000 angstrom, that is equal to 4000 into 10 raised to minus 10 meter. Now we can substitute in the equation. E is equal to 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 by 4000 into 10 raised to minus 10. Value is 4.95 into 10 raised to minus 19 joule. This will be the answer. So like this we can easily calculate the radiation. Okay, energy of radiation by using the equation is equal to h. Okay.